on number 1, we have circle O here, and we have chord AB is 12 inches long and is 8 inches from the center O. So we're looking for the area of the circle. So ultimately what I need here for the area is I need the radius here. So remember the area of a circle here, we can look it up in our formulas here, but it's pi r squared. So ultimately I need the radius. Now recall this 8 units or whatever right there, that is not the radius because it doesn't go all the way. So what I'm going to use is this fact. If we have a segment from the center and it's perpendicular to my chord, that means that that bisects that chord right there. So each one of those lengths would be 6. Now, to get a radius, what we're going to do is we're going to draw a radius intentionally to this point right here so we can make a right triangle. So now, we have the two legs are 8 and 6, and the hypotenuse here, my right triangle, is going to be the radius of the circle. So let's use our Pythagorean theorem really quick here to find our radius. So this would be 64 and 36, which is 100. And so we take the square root of both sides here, so we get plus or minus 10. Now, since it's just a positive measure on a triangle right here, it would just be positive 10. And so now we can throw that into our formula. So 10 squared there would be 100 pi times 10 squared. So the area there is going to be 100 pi. Okay, on number 2, we have a similar situation here where we have a segment from the center that's perpendicular to a chord. So that's going to mean here that those two segments are going to be the same. Now let me read the picture, the description now. So it says, in this figure below, shows a circle with a radius of 5 and a chord of the circle. The chord is 3 centimeters from the center. What is the length in centimeters of the chord? Okay, so this time what I'm looking for here is this distance. Now again, what I have to do with these problems is be creative. And basically all you have to do is make right triangles. So what I'm going to do is I'm going to make a right triangle right here to find this distance. So I'm going to call that distance x. Okay. Now the only thing is we only know one side of our right triangle there. But however, we've got over here, we've got a radius of 5. So that means all radii in the circle would be 5, including this little hypotenuse that I drew right there. So now again, I can use my Pythagorean theorem in my right triangle to find out that little missing length. And that's not going to be the chord, but that would be half of the chord. So we're going to get x squared plus 3 squared equals 5 squared. So that's going to be 9 and 25. We're going to subtract 9, and that's going to give me 16. So we'll take the square root of both sides, so that would be plus or minus 4. Now, of course, it would just be the positive measure. Now, that would be like the left side of the chord. Now, since that's perpendicular, it bisects the chord, so that side's also 4. And so the entire chord there is 8. Okay, number 3 says the diameter of a circle is 34 centimeters, and a chord that is in the same circle is 30 centimeters. What is the distance from the center of that circle to the chord? So let's draw us a picture on this. So here we go. That's a circle, and we're going to have our diameter here is 34 centimeters, and then we have a chord that's 30 centimeters. And we're going to look from the distance to the center to that chord. So I'm going to draw a chord right here of 30 centimeters. Okay. And when you do a distance to something, that distance is always going to form a perpendicular, or they're going to form perpendicular lines. So they'll make a right angle right there. And so this is the value, I'll call it x, that we're trying to find. Now, just like the others, when I'm perpendicular to that chord, and the distance would be, then that's going to bisect that chord. So that one's going to be 15, and then of course over here, that one's also going to be 15. Now, let's just do like we did on the last two problems. We're going to create a radius, so we can use a right triangle to help us find that distance right there. Now, this would be a radius, and since my diameter was 34, that means my radius would be half of that, so this radius would be 17. And so now I can find that distance by using the Pythagorean theorem here again. So you have these chords and the distance from the center, or when you have a line from the center to a chord, if it's perpendicular, it bisects the chord. Now, this is, give me this, if I use my Pythagorean theorem here, that's 225. 17 squared, I believe, is 289. Now, we're going to subtract 225 from both sides. So 289 minus 225 is 64, so that'll actually work out pretty nice here. So we just take the square root of both sides. So we get plus or minus 8. Of course, it's just a positive version. So we get our distance right there from our right triangle is 8. Okay, now this one we have an angle in a circle here. Now the thing is, the vertex of the angle that we're trying to find is not in the center. So if I have the vertex of the angle at the center, the angle and the measure of the arc would be the same here. So if this was 94 degrees, my angle would be 94 degrees. However, my center is right here, not right here. So what we have to use here is a theorem that says that the measure of this angle is half the sum of the arcs. So let me say that again here, write that down. The measure of that angle is half the sum of the arcs here. So x will be equal to 1/2 now times the sum. So another way you can think about that is it's the average of the two arcs. You can just say 98 plus 104 divided by 2, basically. Now, so 98 and 104 is 202, and then half of 202, which is basically just means 202 divided by 2, would be 101 there. Okay, now this says the circle in the figure below has a radius of 8 centimeters, and that's shown. What is the length in centimeters of the arc that is intercepted by a central angle of 60 degrees? Now, let's notice that this question here doesn't ask me about the measure of the arc, but instead it asks the length. Okay, so the measure of the arc would be 60 degrees, but the length is actually how long it is if I was to take it and stretch it out straight and to measure it. So what we're going to use here is we're going to use the measure to find the length by using a proportion. So the way we set up this proportion is we first set up the measure as a part to total. So the part that the arc measures is 60 degrees, and the total degrees in a circle is 360. Now here comes the hard part. The length of the arc right here, I'm going to call it x. The length is unknown. So I'm going to say the part is unknown. The arc length is unknown. Now, what we have to do on the bottom is the total length around the circle. And this is where we have to know something here, and that's just the total length around the circle is the circumference. Okay, so we do a part to total. We're doing that part of the arc length over the total arc length of a circle. So the total arc length of a circle is 2 pi r, which is the circumference. Now, let's notice that the radius there is 8. So 2 times pi times 8, that would make the circumference 16 pi. And now I can find my arc length just by cross multiplying here. So this would give me 360x equals 60 times 16 pi. Notice that my answers are in terms of pi, so I'm not going to multiply this out to be 3.14. I think this is 960 pi. I'm going to punch this in my calculator just to be sure. 60 times 16. It is 960. Now I'll divide by 360. Okay, and that's probably not going to divide out evenly, so I'm going to see what happens here. We'll do 960 divided by 360, and so I get 2.6 repeating. So all I have to do is just put that in a fraction form. So I'm going to take my calculator and just switch it to a fraction. Notice that I'm not pushing in the pi button because, again, all the answers are in terms of pi. So you can just do this. You can just reduce this instead. Those zeros would go away. And I think you could reduce by a factor of 6 right there. 96 divided by 6 is 16. So that would be 16 pi over 6. Now we could reduce it again. So I think I could have reduced probably by something bigger. I don't really know what it was, but I could have. Let's divide by 2. So then that would be 8 pi over 3 there. Okay, this is kind of a similar question here. It says, in the figure below, a sector is shown shaded in a circle with a radius of 4 decimeters. Who uses decimeters? All right. The length of the arc of the unshaded sector is 7 pi decimeters. What is the measure of the central angle of the shaded arc? And this is a pretty challenging question here. Let's look first here, and let's do this. First, the measure of the central angle would be the same thing as the arc. So I'm going to go ahead and set up a proportion with that part. So this unknown measure, so it's not length, it's measure, is x. And the total measure is 360. Now what I'm going to do is set up a proportion for the length around the circle. So let's see what it says here.
Good morning, Washita. It's now time for your morning announcement.
So on our other proportion here, what we need there is the part to the total in terms of length. So notice this is in terms of degrees. This one I'm going to put in terms of length. Now I have to figure out those lengths. So I have to figure out this length and then the length all the way around the circle, so the total length. Now, let's notice that the 7 pi, let's reread this sentence starting here. So the length of the arc of the unshaded sector, by the way, that shaded region is called a sector, is 7 decimeters. So what we're told here is that this length, this part of the circle, is 7 pi. So we can find the total distance around the circle by using the circumference. All right, the circumference formula again is 2 pi r. And you notice they've given me a radius of 4. So that means if my radius is 4 here, that my circumference is 8 pi. Now, if this much is 7 pi and the total distance around the circle is 8 pi, that means that this length is just pi. So now we can do our part to total with our lengths here. So we can do the length that represents this measure, or goes with that measure, would be pi, and then the total length there would be 8 pi. Okay, now we can just cross multiply and solve here. So we're going to get 8 pi x equals 360 pi. So now we'll solve for x. We'll divide both sides by 8 pi. Notice that the pi's will just cancel there. So all we're left with is 360 divided by 8. Okay, and that's going to give me 45 there. Pretty challenging problem.
Pardon me, teachers. Just reminding scholars, banquet participants.
Okay, looks like on this one we're given an inscribed angle here. Let me read my question. It says, in this circle shown below, TR and QS intersect at P, which is the center of the circle, and the measure of angle PST is 30. So that's really nothing new that we couldn't tell by looking at it. Now, what is the degree of the minor arc RS? So we're looking for this arc. And so, by the way, what it means by the minor arc would be the smaller of the two arcs. So if I was referred to the what's called the major arc, the major arc would be the larger arc. A major arc has to be bigger than 180 degrees here. The major arc would have been this one. Okay, so that's not what they're talking about. They're saying the minor arc there. So it's just that shorter arc. And they have a question mark beside it anyway. So we can kind of figure that out. So we're looking for not the length, but the measure of this arc. Now what we're going to use probably are some inscribed angles and some central angles. So with inscribed angles, like angle S right here, the measure of the angle is half the measure of the arc. And when we have central angles, like for instance this angle, that angle is the same as the arc. So now let's use this given angle right here of 30 degrees. So I'm going to notice that this arc is the intercepted arc of that 30 degrees. So that means that this arc here is going to be twice the measure of the angle, because the angle is half the arc. So that would be 60 degrees. Okay, now let's find something else here. So notice I really didn't try to find that arc. I just tried to find other stuff first. So I'm going to note that this central angle is also going to be 60 degrees. Now I've got a linear pair right here. So this angle would be 120. Now I've got a vertical pair right here, which would be 60. Now I can see what this arc is going to be. The central angle is 60, so the arc is going to be the same thing. So it's going to also be 60 there. Now number 8 says the radius of the circle in the figure is 5 inches. So they didn't say that. Let me write myself a note. And then the measure of angle ROS measures 6 degrees. Now we want what is the length of arc RS. Now let's talk about the measure first. So since that's an inscribed angle, the measure of arc RS would be 12 degrees. However, that's not the measure. That's the measure, not the length. Okay, so to find the length, we're going to set us up another part to total proportion here. So the measure part of the arc would be 12 degrees as the part, and then of course 360 degrees is the total. Now let's do the length. So on the length here, the length of RS is unknown. That's what we're trying to figure out over the total length of the circle. Now again, the total length around the circle is the circumference. So my circumference here is 2 pi r, and notice that's why they gave me a radius of 5. So that means my circumference there, 2 pi times 5, would be 10 pi. And now I can just cross multiply here to solve for that x. So now we're going to get 120 pi equals 360 times x. Now we just divide both sides by 360. And then basically all we're going to have to do is reduce this. So the zeros go away. And then 12 over 36 would be 1/3. So that would be 1/3 times pi, which was f right there. Okay, on number 9, we have arc AB is 3 units here. Okay, so notice that's not the measure, but it's the length. And we have the measure of angle AOB is 10 degrees. So we want to know what is the circumference of circle O. The problem is we don't have a radius or diameter, and there's really not a decent way to find the radius or the diameter. So again, what I'm going to use is a proportion, but this time what's going to be missing is the circumference. So let's do a proportion with the measure of the arc. Okay, so the measure of the arc is 10 degrees. So we do the part, which is the arc, over the total, which is 360 degrees. Now, let's do one with the length. Now, we know this time, though, that the length is just 3, and what we're looking for is the total length. Well, the total length would be the circumference right there. So now, let's cross multiply here, and this is going to find me the length. So we'll get 10x equals, and then 360 times 3, I think that's 1080. Yeah, that is 1080. And then, of course, just divide by 10. So 1080 divided by 10 would be 180 here. So it's not in terms of pi there. It's just 180. Okay, in this circle, it says chord AB passes through the center of circle O. If the radius OC is perpendicular to chord AB, so in other words, we're forming a right angle right here, so I'm seeing some right triangles, and I'm thinking of Pythagorean theorem here, and it has a length of 7 centimeters. What is the length of chord BC to the nearest tenth of a centimeter? Now let me read this part again, starting here. If the radius OC is perpendicular to chord AB, now notice it says chord AB, but AB would really be the diameter, and has a length of 7, okay? So we got, this is a length of 7. So that should tell me that the radius here would be 3.5. Now, my other radius is also 3.5. And now since this is perpendicular, I have a right triangle, and I can find the length of chord BC right there just by using the Pythagorean theorem. So we can do 3.5 squared plus 3.5 squared. Now, if you know your 45, 45, 90s right here, you should know that the length of that hypotenuse is going to be 3.5 times square root of 2. Of course, you don't really have to know that to answer this question. Let's just do it this way by the Pythagorean theorem. So I'm going to type in my calculator here, 3.5 squared plus 3.5 squared, and that's 24.5. 24.5 is equal to c squared. Now I'll take the square root of both sides, and then the square root of 24.5. Okay, I'm getting here that this is approximately 4.95. It's not right on this one. Okay, found my mistake here is I didn't read it very well. Let's go back to this part of the sentence, and I'm going to really kind of start over. It says if the radius OC, so it's talking about OC here, is perpendicular to chord AB and has a length of 7 centimeters. So when it says has a length of 7 centimeters, I thought that was referring to AB. However, read it again, and that's referring to OC. So the radius here is 7. Now, let's get back to finding it here. So here's my chord that I'm looking for. Now, we should know that this radius, that's a radius also, would also be 7 because all radii are congruent. And now I can just use the Pythagorean theorem again to find that chord. So we'll say 7 squared plus 7 squared equals c squared. So that would be 49 plus 49 equals c squared. And then 49 and 49 is 98. And then we'll take the square root of both sides. Now notice, normally like in Algebra 2 or Advanced Math, what we would do, we kind of break that down into 49 times 2, and then that would be 7 square root of 2. But notice, it's not in a radical form, so what they want us to do here is just to type this in the calculator, okay, or to estimate it. And you could estimate it this way. That's pretty close to 100, and the square root of 100 would be 10. So that's probably the closest one. Now, if I actually type it in my calculator, the square root of 98 does come out to be 9.9 if it's rounded to the tenths. Okay, now we've got a little circle graph here. So I'm going to use a lot of part to total relationships here, proportions, to figure this out. It says last month, Lucy had a total expenditures of $900. So that's pretty important here, that in terms of money, the total is $900. I'm going to use that in the proportion probably. Now the pie chart below breaks down the expenses by category. The category in which Lucy's expenditures were the greatest is what percent of her total expenditures to the nearest 1%. So I'm looking for which one was the greatest in terms of a percent. So obviously here the greatest one is clothes. Okay, she's spending $254 on clothes. So let's set up a proportion here with money in percents with a part to a total. So the part that she spends on clothes is $254, and the total is $900. Now, in terms of percents, We don't know what percent that is yet, but we should know that the total percent is 100%. Okay. And also note, you could, a lot of these questions on the ACT, instead of asking you for the percent, they might ask you for that angle right there instead. So if it was looking for the angle instead of a percent, I would have used x degrees over 360 degrees, the part to the total there. Now, let's just cross multiply and solve here. So we get 900x equals 254 times 100% there would be 254 with two zeros onto it. And now we're just going to divide by 900. So let's see, 225,400, excuse me, divided by 900 is 28.2%. Okay, now it says to the nearest percent, so we would just round off right there. The 8 would stay the same. So there's 28% right there. Okay, now we have another one here for a pie chart. It says the circle graph below shows the distribution of registered voters by age for a community. Registered voters are randomly selected from the distribution to be called for a jury duty. Now, this one says, what are the odds? This is something that I haven't talked about yet. In the range, not in the age range, that the first person called for jury duty is between 25 to 35. Now, the difference here in odds and probability, the odds, instead of the probability would be how many you have over the total, the odds would be how many are you selecting versus how many you are not. So in this case, let me read through this again. We're looking for the age range of 25 through 35. So the age range here from 25 to 35, this is the 42%. So 42% is the amount that is. So the way that we would find the odds here is we would do 42% to, instead of 100%, which would be like probability, you would do the probability, you would do the ones that are not. So you do the ones that are, the ones to the ones that are not. And so the ones that are not here would be the rest of this, okay? And instead of adding up those percentages, you could just say, well, it's the ones that are not 42%. So you could say 100 minus 42, and then that would be 58. Okay, so we're just looking at the ratio of 42 to 58 here, I think. Now, we can reduce here by, I don't know, probably a 2. So this would be 42 divided by 2 would be 21, and 58 divided by 2 would be 40. 58 divided by 2, calculator. Calculator says 29. So 21 to 29. Okay, so again, probably not doing a good job of this. The odds are basically the ratio of the success, or the number of the successes here over or to the number of failures. So the ones that are 25 to 35 versus the ones that are not 25 to 35. So the ones that were not were all of these, okay, which was 58. So 42 to 58. Okay, now this one, my chart here refers to numbers 13 through 15 here. Copy my chart real quick. Okay, so we have a poll of 200 registered voters was taken before the election for the mayor of Springdale. All 200 voters are indicated which one of the 4 candidates they would like to vote for. The results of the poll are given in the table below. Okay, so we have the number of votes per candidate. Now, the next one says, what percent of the voters polled chose Whitney in the poll? Here again, I'm going to use I love part to total to get to percentages here. So let's notice that Whitney got a total of 30. So we'll have 30, now that's how many she got, to the total number of voters, which was 200. So you have a part to total. Now realistically right there, most of you can figure out that you just get the percentage of that. But however, a lot of us, we like to use proportions with percents, and I totally get that. So if we did this in terms of percent, we would do the part of the percent that we don't know to the total percent, which would be 100. Now, that you cross multiply to solve that. Now, really and truly, we should just do 30 divided by 200, and that's 0.15. You divide that right there, and so that's just 15%. Now, on the next one here, let me get my chart in front of me here. It said if the poll is indicative of how the 10,000 registered voters of Springdale will actually vote in the election, which of the following is the best estimate for the number of votes Lou will receive in the election? So this is a good part to total proportion here. Now, he or she, whoever Lou is, got 80 votes out of 200. Okay, so 80 out of 200. Now, that was just, I guess, like a poll or something. Yeah, it said it was a poll. So how would it work if we had 10,000 actual voters? So again, we could do a part to total. So we don't know how many of those 10,000 would vote for her, but we know we have a total of 10,000. So here we go again with a part to total ratio here, and we can just cross multiply with this. So we'll get 200x equals 80 times 10,000 is going to be 800,000. And then 800,000 divided by 200, okay, is 4,000. Okay, now let's go to 15 here. Let me move my chart. Okay, it says the information in the table were converted into a circle graph or a pie chart, then the central angle for the sector for Gomez would measure how many degrees. So let's notice what Gomez was here. So out of the 200 that were polled, 40 voted for him. So let's do a part to total again. So 40 out of 200. Now, if we're doing the angle measure for that central angle, we don't know the angle measure, but we know the total measure for the angles would be, on my pie chart, would be 360 degrees. So there we go again. We have part to totals here that are really good, especially in pie chart. Okay? The percentages, pie charts, part to total, or anything for the proportions are usually really easy to set up. Kind of understand them. Now, we got 40, cross multiply, 40 times 360 is 14,400, excuse me. And then 14,400 divided by 200 is 72. So that'll be 72. This will be in terms of degrees right there, since it's an angle, 72 degrees. Okay, on number 16, now we've talked about logarithms, so I was just showing you guys here just an example of what a logarithm question would look like on the ACT. So there's two forms of log questions. One is like this. The other would be applying the properties of a log, up to like two logs, like combining two logs with a plus or combining two logs with a minus. Okay, so should we know that? So since we know logarithms, we know this is really, really easy how to evaluate this. So we have log base 2 of 8, and we want to know what's this value. So remember what this number to this power equals this number. So 2 to the third power would be equal to 8. So we should be really good at that. All right, I think that's all.